Perfect. I think we can probably get going as the techUK logo will slowly appear behind us. So today we've discussed several emerging technologies, including AI and quantum. However, underpinning these technologies is more of this elusive term, high-performance computing, or what UK government now will sometimes call the future of compute. And it is this underpinning technology that this panel today is going to discuss, in particular its integral role for ensuring that the UK can become a science and tech superpower. This technology quite often is viewed as the domain of academia, but what I really hope that we can show today on this panel is that in fact there are so many opportunities for businesses to adopt and leverage this technology for their own benefit. Of course, that is a huge topic, and I'm very glad that I'm not here to try and answer that alone. And I've got a fantastic lineup of speakers who will be joining me here today. So starting with Ben Bennett, who is the Director of HPC Strategic Marketing at HPE. We've also got Adong Zhu, who is the Head of Semiconductor Capability at Cambridge Consultants. Kate Royce, who is the Director of the Hartree Centre, and of course Melanie Garson, who is the Cybersecurity Lead at the Tony Blair Institute. Thank you all for joining me here today. So let's get straight into it, shall we? And Ben, since you're sat next to me, I'm going to go to you first.
Words like thanks.
Why did you think we went over here?
So let's start by briefly describing the term future of compute. Why do we use future of compute when we decide to talk about supercomputing or HPC?
Cynicism prevents me from saying it was because the UK government woke up and said, oh, we have no idea what we're doing, so anything we do is the future of compute. However, back in 2021, there was a chief scientist report that came out that said the UK appears to be lacking direction within the use of its scientific supercomputing. This is before AI became popular. And not just the lack of direction, but a lack of roadmap, a lack of investment, as well as ownership. So a panel was chosen. I believe Sue Daly from techUK was on it. And what we have here is a report called The Future of Compute that says this is where the UK sits industrially, how it compares to its peers, and I'm sure we'll hear lots more about that, so I won't get into the joy of that. But also these are tools. These aren't computers for computing's sake. How do we make them available? How do we make them useful for industry? And so it's a 10-year plan. The first item on the list was to fund ARVR, and that's happened. Ironically, the first item on our recommendations was to put a strategy and a roadmap together. They are due this year. So when we talk about the future of compute, we talk about the provision of high-performance computers. And these high-performance computers can be used for traditional scientific research, the domain of the academia, the support of industries to solve very large problems, and to look at the emergence of AI, where you have large data sets to determine what we can extract from that data. So the future of compute does not mean what your new Mac looks like, what your new PC looks like, but it does and should have an impact on the UK and its capability.
Oh, what a great way to get us started. I think that's covered all the definition points. But Kate, I actually want to come to you because as part of the Future of Compute review, they highlighted the public infrastructure that we have available and access to. And the Hartree Centre is one of those institutions. So what are the UK's HPC facilities and how do businesses even go about accessing them?
Right, so the UK at the moment has a whole host of HPC facilities all around academia. So we have what we call tier ones and tier twos. I would say that these days that's a misnomer. Tier twos used to be considered smaller than the tier ones, but these days, because of the way funding is arised, it doesn't make much sense. Hartree Centre was set up to have a facility, HPC facility, specifically designed to support the R&D elements of UK organisations. So that's outside the academic world. Academia can come, but we are primarily focused on organisations. And this enables all of us to get access into HPC, and we can provide that support and that skills generation and supporting the organisations to upskill their employees so that they can make the most of some of the stuff that Ben's already highlighted. Generative AI is the new kid on the block, but isn't new at all. There's quantum that's coming around the corner, which I know you've already all talked about as well. We're looking at how do you converge those technologies together, which is part of the future of compute. It's not in business. You're not going to use just one technology. You're going to converge those technologies to provide the solution that you've got, that you need to do. How do you do that? And then how do you do that ethically and responsibly?
I do have another question I want to ask, but you just shook your head at quantum being around the corner. So I thought I would make it a little bit more controversial and actually ask you about that.
Okay, so people have been telling me quantum is due in the next 25 years. They've been doing that for about the last 25 years. I still think the statement is correct. I believe we will have quantum in the next 25 years, and I'll probably give you the same answer next year. The issue becomes a function of engineering. Is at the moment we're only building what we call noisy instances of quantum bits. And noisy means that you can't take the same problem and get a repeatable answer out of it. So quantum also doesn't do numbers, so it's no use to the banks, it's no use in the home, and so the commodity value of quantum is never going to drive the price points down. You're never going to see a Beowulf of quantum machines. What you're going to see, very large institutions for where quantum has some very interesting capabilities. But to feed those quantum machines, you are going to need extremely large supercomputers to generate a series of possibilities for the quantum machine to help. I know I'm fairly cynical about it. I know that there is a lot of money spent in quantum. I know there are devices that can literally see round corners. I promise you, they really do exist. But if you look at the engineering gaps between the 1,000 qubits of one state to the 100,000 qubits you need of a different state, I still say it's 25 years when we'll have a machine that you can provide a drug problem or a mechanical problem that you can say, help me solve this. Yeah. And it is affordable. Mm-hmm. And this is the point, is if you can't afford to build it and run it, then as far as I'm concerned, it doesn't exist.
Hey, Dong, you look like you want to come in.
I just wanted. I think I agree with Ben. There's a long road ahead. But I just want to emphasize it's a sort of graduate, it's sort of evolution. It's not like a 25 years suddenly.
Oh no.
It's a graduate, like you said.
Yes.
The qubit getting more and more, and there's a functionality getting more and more. Then the price point gradually come down. So it's a journey. That's what I want to say. Yeah,
of course. Yeah. Now, I will stick with you, Adong, for the next question then. So obviously we had a tiny tangent there to quantum, which there will be very real use cases for down the line. But right now, high performance computing is being used to drive some real differences for businesses. What use case do you get most excited about when you talk about high performance compute?
I think that the things are just, what I think is it really is the emergency of this, HPC, AI, quantum computing we're talking about, is really those merging together. And I think that's really exciting. And also there's so many potential use cases, for supercomputing. And, we focus on quite a lot on the scientific research, academic research, and also there's a vast the industrial applications, and so that's really really exciting. When we looking at the robotics, automations, the people talking about the industrial 4.0, digital twins, all that sort of thing, and that supercomputing really coming soon. It really can help. And so, yeah, I mean, the other thing is, maybe I'll touch on a little bit later on, when we're talking about future compute, I mean, we're not just talking about HPC, We really need to also looking at on the component level, on the semiconductor level, and there's loads of innovation going on, yeah.
I actually want to ask Melanie a question around that. Just before we do, Kate, just to round off this section on high performance computing, what is it and what is the opportunities? Do you have a use case that you're particularly excited by?
I think my excitement to bring those two areas together has been some work that we've recently published around looking at, it's on breast cancer, and it was looking at not just being able to use an AI that said, this is cancer, this isn't cancer, but using a hybrid between a classical compute and quantum to see if we could determine what type of cancer that there was a possibility of having. And we proved that by using a hybrid approach, that you could see an improvement in the identification of subtypes of cancer. And that's incredibly important for anybody who has a relative or has gone through this sort of thing themselves, for medics to know quickly off the bat what type of cancer they're dealing with without having to do a huge amount of invasive procedures. This is going to help revolutionise what we do. My colleagues are absolutely right. Full industrial use of quantum is a way off, but I do believe this hybrid approach is where businesses are going to see, and we're seeing that in all sectors. And absolutely, quantum is not the answer to all your problems. It's very good at probabilistic problems. It's very good when we're looking at uncertainty, so Monte Carlo type applications. It's not good for everything.
Yeah.
Deterministic, in fact.
Yes.
Yes, you wouldn't want to balance your books on a quantum computer.
No, but the future of compute is going to be this hybrid approach.
Yes.
Quantum and HPC. Melanie, based off that conversation that we've just had then, we're gathering here it isn't just about the HPC or quantum infrastructure. It's very much about readiness, routes to access, and everything that goes around enabling people to leverage this technology. What is so critical to adopting high-performance computing? I know you've done a bit of research in this area.
Yes, thank you. So the bit of research being referred to is that we're about to launch an index and data visualization tool that looks at actually future of access to compute, which is a slightly different term than just like future compute, where we've looked at 55 countries across 25 indicators to try and look at both to see where there is potentially a global divide that's going to sort of the next level of digital divide, and how we're going to provide to close that or think about the different paradigms for it. But also it provides a very interesting look at the different levers that exist within the system that countries need to look at to actually increase their own performance. So to think about where do you invest into to actually deliver the impact. So from the global level, we have countries that have bought a quantum computer that sits in their basement somewhere, never plugged in, because they don't have the infrastructure system to do it, but they want to rank on another index that is in the top 500 countries with supercomputers. So how do we think about that? What we're finding is, and I can go into more specific UK sort of insights, that what we're having overall, it still comes down to most of the world, or most of the world surveyed in our index, doesn't have the strong baseline foundational infrastructure to support any of it. So in some countries at the extreme, just basic reliability on the electric grid, and that's something relevant to England as well. We're going to have to look, as we're seeking to build exascale, sort of the electrification of the grid and really supporting just the base level power that we're going to need in a sustainable way to do this is going to be absolutely critical. The skills picture. It's thinking about all this investment into different elements, but having the skills to be able to operate it in a different way. Data centers and co-location, sort of UK sits around 5th on sort of our index where it has it. Still not going to be enough. So for the vision of where my colleagues here are trying to get, the index, we've still got ways to go in the UK to be able to get to those baselines to do it.
So to get to this, we need to figure out things such as skills and access. Is there anything else specific to the UK that it really showed up as quite alarming maybe on your index?
Well, there's things that, we sort of thought we were investing well in and beginning to sort of have catch up. So we sort of, the UK would sit sort of where the index, so to like sneak preview, is obviously you've got US and China sort of way ahead as sort of, and the UK sits alongside, say, Germany, Canada, sort of the established players in this picture. But so for something like the research access, we're talking about research access to quantum. Previously, there was quite a bit of investment. UK probably ranked around third in that, but Germany recently has massively invested and climbed up. So I think it's having this really forward-looking picture of where you're going to invest into and making sure that that metric, and this is what we hope the index does provide insights, is really delivering what's going to be the impact from the investment and where does that sit across the whole system.
Thank you. Ben?
Yes, the Future of Compute review talks much more about investment in people and skills than it does about computers. It's not just building a big piece of tin and they will come. If you look at what the EU has done, the EU has co-funded very, very large machines, and they have made the people hosting these machines hand over, free of charge, 20% of these machines for use for small and medium enterprise. To put that into context, the Finnish machine Lumi, if you have 20% of Lumi, that's almost exactly the same size as the UK's national resource. And so it would mean taking the whole of the UK's national resource and giving it to small and medium enterprises to learn and to use and to play with those machines. And that entry point is where Europe is investing. And it's also where the US investing with the National Science Foundation on very large machines. You only have to give a few percentage points away to have access to very big machines. So even though I'm a bit of a tin hugger, the biggest problem is not the tin, it's people, the investment in people, and the UK government having that strategic vision that says, we're going to buy an exascale machine, we're going to put it there. In 3 years' time, we're going to buy another one. And then that one's going to run down. Where the heck does this one go? And just to put it into context, these machines consume 20 or 30 megawatts of power. And these machines cost 40 odd million pounds a year just for the electricity bill. Be grateful you're not in Japan, where it's 10 million pounds per megawatt. So the disparity in electricity in the grid, everybody's going to have electric cars, and we're going to go find another 20 to 30 megawatts for another data center in the next 5 years. Oh, and by the way, it takes 5 years to build power supplies and data centers. So it's the work that these fine people do. I never thought I'd say that about Tony Blair. That lays out the future and says the future is now.
So the investment we're talking about here is not in compute, it's not just in compute, it's not just in people, it's also around the actual hard infrastructure and actually understanding that this is a whole problem. And where I think the UK has looked at before is it's looked at things in isolation and not looked at things together. And the other thing we've been talking about, particularly within the academia world, is how do we have an ecosystem? How do we have a federated system of supercomputers? So just as Ben has been describing that, well, you've all got access to any machine, it doesn't actually matter which machine you're on, as long as we have interesting and exciting architectures that are novel so that you can experiment and get on and start using these things. On the other side, you need a skilled support workforce that can support you to get to the level of utilisation of those machines that you may or may want. Once we've trained you all up, you don't need us anymore. But at the start, particularly in virgin areas, particularly creators, for example, an area we're trying to sort of encourage at the moment, don't have the expertise. So we need to be supporting them to get online.
So I think Adong and then Melanie.
No, I mean, I think it's a really important issue on the access to the facility. I just want to point out actually, the people here being in industry for a long time probably remember, UK actually did something very great when we had this 3D printing stuff, or and at that time, I remember when I was in industry, and you can subscribe with those facilities are set up in university like Southampton. Those are national facility, and then you can subscribe or just pay annual fees. Then you can use it. Obviously 3D printing is nothing new now, but at that time it's very rare. So we did something right in that sort of scheme. I think if we could do something similar. And the other thing I would want to say is, like Ben said, if you get access to like 20% of that facility. I used to work for a chemistry company for a while. I don't know why I'm in chemistry. I'm a semiconductor man. But anyway, so we're looking at the material discovery. Chemistry, when you're looking at the EV battery materials, and it's mind-boggling. So much thing. Then you want to have, I wish we have access to supercomputing to do this material discovery, a bit like a pharmaceutical drug discovery. It's very similar. But we have no access to that facility. And now I'm working for a FTSE 100 company, let alone the SME. It's kind of that sort of thing,
Yeah. And I think the other thing that's kind of missing from this picture a little bit, and something that we clock in the index, is obviously the other big geopolitical players, the tech companies that are in this. And if we look at the extent that, the UK is investing in, like Meta, it's just sort of brought that 30 times the amount as that the UK has brought into it. And with research access, as you're coming back to, we used to have paradigms where you could come to universities, having situations now that researchers globally that can't find the places to do it are going to the private companies to do it under their terms and conditions, which doesn't necessarily provide for the sort of IP protections that you'd have for doing it through a university and doing through an academic institution. And that's a two-way thing. So one of the things that UK does do well is having, or countries that are doing well, have that relationship with the big tech companies that can provide the campuses for the skills training and whatever. So it's thinking about how we harness those campuses and skills to be able to build the ecosystem, but also making sure that we're competitive with those other players as well.
So this has been an absolutely fascinating conversation so far. I think let's maybe recenter some of those key points that we've mentioned there, particularly about the fact that even if the UK has been investing, we still only have around 4% of the international capacity for publicly owned compute. And that is why we had the Future of Compute Review, to set that long-term strategic vision that we need to develop compute infrastructure for SMEs to be able to even think about accessing, or industry, or again, supporting academia as well. So let's maybe talk, because we've talked about the challenge there, maybe let's talk about what comes ahead now. What do we need to do to get to the place where we can support UK businesses with compute? There was an announcement of around 900 million with the Future of Compute Review, about 300 million of that going towards an AI resource. Also in that, though, is the funding of a potential exascale computer and everything we've talked about in terms of access and skills as well. Maybe let's just break that down a little bit. So, Adong, why is exascale also an important part of this conversation? I
think, again, as we touched on earlier on, there's a number of key applications we do require, this, high performance computing. And one clear example, as I mentioned, is a material discovery. It's I don't know. I mean, UK traditionally is very strong in material science. We've got the graphing centers, we've got 2D materials, and somehow we're not leading on things like a battery material. And now, then if we have this sort of computing facility, that really really take it off. And also we're traditionally very strong in pharmaceutical, the drug discovery. So I think it's so important to this country. And now we involve quite a lot on the AI, and also I think the German also stole the show in a sense, is they're really focused on quite a lot of industrial automation. So we're talking about Industry 4.0 quite a lot, and we're talking about, again, I've been in industry for 30 years. I mean, I remember those times you always build up pilot lines, doing things until you move to the main line. But now you're doing digital twin. and doing, I call it the Internet of Simulation. Now, all those are so crucial to have exascale computing. Will help, greatly in terms of productivity innovation. Yeah.
Fantastic. And then, of course, there's the announcement of the AI resource and why that needs to be funded as well. So, Ben, why is that also an integral part of the future of compute review, and how do we get to that and what we need with that?
So AI is neither. It is not artificial and it is not intelligent. AI is about understanding the data you have and getting insight from that data. We've been doing it for years. AI has arisen through chatbots and the consumption by the masses of understanding what AI could be and could do. If we look at it from the scientific premise, and the reason we need to start looking at it is the amount of data that is currently available. We have 50 odd years of good scientific data that we've looked at once in the 50 years ago, the 49 years ago, the 48 years ago. We haven't gone back to a lot of that data, reanalyzed it, re-looked at it, re-understood it. The stuff they're doing in Edinburgh right now, where they're taking the health records of Scotland and going through all the health records and re-evaluating that data. What can it tell us? So I think AI is both a very interesting tool. It's very useful in industry. It allows us to predict workflows, look at tools, stop robots falling over. And I don't mean toppling over, I mean stopping functioning because the tools are not working, or there's predictive maintenance, visual inspection of components. AI can do that much faster than humans, and it doesn't need to sleep or any of that. I think that the work that's being done at Bristol on the Isambard AI machine is about looking at science, looking at AI, looking at how we can use some of these techniques to get more out of our investment dollar. Science is expensive. And if you go back many years ago, somebody in the Department of Energy in the US said, we have a problem. This is a very unpopular problem, by the way, but it's just a fact of life. I have a pile of plutonium weapons stored in a cave. What happens if one of them goes off? What happens to the other plutonium weapons? Now, this is an experiment that is banned under various treaties, but it's also not one you'd want to do. So it started the American Strategic Compute Initiative 40 years ago that said, we need to be able to simulate experiments we can't do. And that we've started to do with car crashes, airplanes falling out the sky, bird strikes. So we're using computers to do things you'd really rather not experiment. And there was a big NVIDIA conference a few years ago, and they're talking about AI and autonomous driving. And the day before it took place in San Francisco, a car ran over a little old lady pushing a bicycle. It's terrible. But that was the news. Autonomous driving is dangerous. The fact that, 50 or so other deaths had occurred on the streets at the same time by humans was not mentioned. But the point is that the autonomous car had never seen a little old lady pushing a bike, so it didn't know what to do. So one of the things that's been worked on is, if you read, and this is going back to Jasper Carrot, if you read all of the claim forms for insurance for why accidents happen, when you've finished laughing, you will find there are hundreds of things that you do not believe and that have happened once or twice. So you won't be able to train a car to recognise them. So you use a very large computer to create near-perfect visualisation of a dog running out of a butcher's with a string of sausages, and you teach the car to stop, or somebody up a ladder with a bucket. And so you can use very large computers doing their simulation to help train AI. And I think we're going to see more of that. We're going to see a closer link between data sets, the use of AI to pull out suppositions, and then using science to help us provide real-world examples for AI.
Amazing.
But when you touch on the insurance, I think the HPC or supercomputer has a huge beneficial impact on the insurance industry.
Oh, yeah.
Yeah.
Yeah, you can... Yes, you can have a look at the weather storm coming in and go, right, everybody has a dodgy policy down on the southwest coast, cancel their insurance now.
Actually, that's what they call it. There's a new phenomenon called parametric insurance.
Yes.
And that's exactly for the disaster. Yeah. And again, supercomputing would be perfect.
And of course, that is what Hurricane Katrina highlighted in 2007, wasn't it?
Yeah.
Where we basically saw a worldwide depression because of insurance companies not understanding that casinos in boats and casinos on land were two different things. They insured them the same. And when Hurricane Katrina hit, all the casinos on the boats were completely wiped out. And if that was what you insured, you went bust. And the ones that had insured those on land managed to survive. And of course, that created a worldwide recession. So these things can be humorous, but actually they are... Because we're globally connected economies now, they're incredibly serious. To understand climate variation, to understand the impact that then has on our resilience, and then our financial sectors is absolutely critical going forward.
So I believe we did have a question from the audience. So if anyone else does have a question as well, please do. But we'll go to you first. I believe they're just bringing a mic. Sorry. No, further ahead, Harriet. Thank you.
I had two questions, really. The first one, there was a partial answer from the middle of the table, but I'd like to know more. When we talked about making 20% of capacity of high-performance computing available to SMEs, I was curious to find out what kind of use cases SMEs had that needed a supercomputer.
Yeah.
And secondly, you talked rightly about the cost of, the operating cost of doing these things. So is the key determinant going forward really going to be places which have low energy costs? For example, should we be building them in Iceland, for example, rather than countries which have historically enjoyed human capital?
Well, some places are, aren't they?
Well, Lumi is in
the Arctic Circle.
It's a system that has free electricity and free cooling. And ironically, one of the most expensive places to build a supercomputer is Alaska. The supercomputer system in Fairbanks, it's too cold for the water to run during the winter, and it's too hot during the summer to keep it cool. But I'll go back to the SME question. So Europe made a policy decision that said 20% of these machines will be made available, and they've also set up centres of excellence. And these centres of excellence are based around vertical areas such as automotive, drug design. And if you are in, for example, the automotive sector, you're either building something for a car or you're building something for the roadways or for the infrastructure. We have models of cars, tyres, braking systems, how things crash, how people react. So if you're a supplier and you want to build a new windscreen wiper, for example, you can go to a virtual automotive centre. There's one in Germany attached to Stuttgart, and you can get a model of a windscreen and the airflow that runs over the windscreen and how it changes in the summer and in the winter. And they will teach you to build a model of your windscreen wiper blade with the material and how it's mounted, and you will then be able to see how it works. Now, if you were a windscreen wiper blade producer, so for example Bosch, they already have large supercomputers. But if you're an SME and has a new design or a new idea that you want to try out, you probably don't have those machines. So you potter along to the virtual automotive centre and say, the EU sent me, but in German, and then somebody will very carefully sit down and help you. The same with people doing, and I hate to say this, people doing fizzy pop and crisps and all those other things because of the chemistry and the packaging. Now, there's some famous stuff many years ago. The people that built Pringles wanted to increase the throughput for the factory. And so they turned the oven up and then ran the conveyor belt through the oven faster. What happened is the Pringles started flying off the conveyor belts into the oven, catching fire, disappearing. So they turned to their local university and said, how do we redesign Pringles so that the air flows over them so they stick to the conveyor belts? And there's horrible things that Procter & Gamble do to determine whether nappies are leak-proof. Yes, they do. What happens when you drop a bottle of bleach? You know, about packaging. And so small companies, there are models out there, and this goes back to the digital twins. So it's a political will.
So I would say the UK does have that.
Yes.
It's called the Hartree Centre, and that's what we are actually set up to do. So although we might not be in Europe, and we are in Europe, do come and talk to the Hartree Centre as SMEs, because all these things that Ben has mentioned, I can give you case studies of stuff that we have allied done for organisations and SMEs in the UK. It's a shameless plug. But I just wanted to say, don't worry, you can come to us.
However, would you like more, and would you like the government to pay for it?
I always love more. We do have a government grant, HNCDI, so that's our public-private partnership with IBM, and we are working with the UK government to encourage more projects and stuff. And obviously there's colleagues up there.
Yeah, we are getting quite close to time, but Melanie, it did look like you wanted to come in on that point as well.
Yeah, I think it was just on the environmental sustainability point, which is, yes, there's, there's sort of growing centres being built, submerged in Norway in places where they can have it. The other key to that is it's thinking about how we better use the energy generated in the process to make it more sustainable. So it's not just it requires this power. There's also opportunity to use it to create the power itself. Yeah. So I think
and the reuse
part
of the heat
picture
that comes out of the machines.
Yeah. Can I just, conscious time, just add a few words about the sustainability side of things? That's my grave concern in terms of the future computing, in terms of energy consumption. When we, if you look at the supercomputers, how many GPU they put in, to me, the future computer, one of the key elements is really how you do low power design. And really need, how they say, get this damn power down, because you cannot get this, they said, out of control. Again, as I said, down to component level, and we've been looking into can we do analog design, for example? Can you do hybrid? Can you do photonics? All those, I think, is a really important equation. So, people ask me, so what's the future computer? Sometimes I say, we're not good as far as I say future is analog, but will be the large element of analog. That's my prediction, because that's you really get the power down.
So we are pretty getting close to time, but there is a wealth of knowledge on this panel, and I did see that a few more people did have their hands up. So it's a quick question, okay.
So as a communications provider, which we are, do we need to rethink the infrastructure that we build and how we build it to accommodate supercomputing, or is it just a case of fiber's fine and I can tell everybody that our network is supercomputer ready?
Is that maybe one for UK or?
I'm going to hand it to Ben.
Okay, so one of the things that we do is we build supercomputers. We build them so they're affordable. And yes, we'd love to have lower power devices. People said that ARM was going to save the world because it's a low power device. Unfortunately, a well-known Scottish gentleman said you can't actually break the laws of physics. If you're turning transistors on and off to solve numerically intensive, they actually found that ARM-based supercomputers consumed exactly the same amount of power as standard x86, which was predicted. Is there a change and a focus? Yes, if you look at Frontier was the first exascale machine, ran at 20 megaflops. It is 10 times the power performance of its predecessor.
Yeah.
And the US government has told us that the next machine they buy from us will be 10 times as powerful per watt. And this is where we start saying things like, really? And we're going to have to look at, the interconnection. It's going to have to be optical. We're going to have to look at heterogeneity. We're going to have to build the right components. But this means that investment in people who understand what's coming, the novel architectures that Kate talked about, there's no point buying a machine, opening it and going, ooh, I wonder what I'm going to do with this, and now spend a year porting your codes, getting it running, and then 4 years later, another brand new machine comes up. So what the US has done, and what we have asked, is the US has put a $200 million program together that abstracts the hardware from the software and said, you write your code efficiently and the machine underneath will deal with it. It's not enough money. They know it's not enough money. The UK government hasn't, I'll be polite, hasn't quite got that far yet.
No.
But it has to. We have to abstract that.
Mm-hmm. Yeah, and just super quickly on that, just thinking about where the communications infrastructure sits, certainly from what we're seeing on the index and one of the divides, is that it is the access to the cloud is absolutely sort of pivotal for where we're seeing the divides, with actually from our indexing, only 46% of the countries on the index have the kind of access to the cloud that they need to even get near to any, or not even into lids, like near to this picture. So coming back to those baselines, communication, infrastructure, internet accessibility is still absolutely crucial for many parts. And we're not just talking about Western, the big players we think of. It's actually significantly larger, almost 50% sort of level of the countries that we looked at are still falling behind there.
So we are at time, but for my final question, I want all of the panelists to future gaze now. I want you to think about that term, future of compute. And in an ideal world, which we don't live in, but in an ideal world, what would the future of compute look like here in the UK? Ben, I'm going to start with you and then go that way.
Enough resources in terms of people, power and computing that if you think of a problem, you can go and find a way of getting it solved.
Thank you, and thank you for joining us here today. Adon?
Yeah, well, I mean, the two aspects. The one is we have a computing which is super efficient, and without have a completely new architecture, have a really power efficient, but also great access to the business, by the business. Yeah, the access.
And for me, so growing on my two colleagues, I want to see the whole of the population within the UK and globally being AI literate and data literate, because that is going to be the key for us to make the most of these technologies.
Thank you.
I would go one step ahead from enough capacity to excess capacity, so that we can actually almost have like a digital Peace Corps where we can send people actually to the places that need it, or be able to share resources with those places that need it, to make sure there isn't a divide here.
Thank you, and thank you all for joining me on this stage today. Again, massive wealth of knowledge on this stage. If you have any further questions, I'm going to throw you all under the bus, but please do reach out to these guys. They'd be more than happy to continue the conversation that we've had here today. That is not the only compute session we've got. So coming up, we do have a presentation from Rich Harding from the Hartree Centre as well, and John Weatherhall from the CGA Simulation, who are actually going to deep dive a little bit more into what a use case is, and then we'll be moving on to a short networking break. So I'd like to welcome Richard and John to the stage, but also thank you to the wonderful speakers for getting us started.